So hello everyone, welcome you all to this new video. So in this video, I'm going to continue with the model paper solutions of the subject Intelligent Systems and Machine Learning Algorithms. In the previous video, I had discussed with module 1 model paper solutions, that is question 1A, 1B, 2A, 2B, the previous video. So those who have not seen that video, please go and watch it. It is available in our channel. And in this video, I'm going to discuss with module 2 solutions. Okay, already I've discussed module 1. Go and watch it if you have not watched it. So that's all guys. Let us start with the video now. The first question of this video is from module 2, that is 3A. What are the 5 components used to formally define for a problem? Okay, that is to formally define a problem for a problem solving agent. 5 key components are considered. Okay, the module name is problem solving agents. Okay, how the problems are solved for basic different categories. Okay, so to formally define a problem, we have 5 key components. First, we should be applying the initial state. Okay, this represents that the starting point of the problem. For example, if the problem is to drive an Arad to drive from Arad to Bucharest, okay, these are the two city names. The initial state would be the agent's location to Arad. Okay, so this would be the initial state. Okay, they have given one example. Okay, the problem is to drive from Arad to Bucharest. In order to drive from one city to other city, you should be having the location in your mind. Okay, so that should be planting a location from one city to one city. Okay, from that city to other city, and finally you should be reaching our destination, that is in this case Bucharest. So this would be our initial state of building a location in your mind. Okay, next is actions. What are the actions needed to be taken to reach that location? These are the possible actions or operations that the agent can perform to transition from one state to another. Actions could include turning left, turning right, going straight, accelerating, or braking. For example, if you're driving a car from one city to another city, actions, these are the set of actions you should be taking. That is, whenever you need to turn left, you would be turning left, or your car or any vehicle. Whenever you need to turn right, you would be turning right. Whenever you need to be going straight, for example, in highways, you would be going straight. Whenever you need to accelerate, if you see that there are no vehicles around you or near to you, from far distance, it is completely, the road is clean, so that if you want to reach to within a short time or short instance of time, so you will be accelerating your vehicle or braking whenever you see that the vehicles are coming near you. Okay, so these are the set of actions that need to be taken. Next is goal test. This is a criterion used to determine whether a given state satisfies the goal of the problem. For instance, in the Arad to Bucharest example, as I've told you, the goal test would check if the agent has reached Bucharest or not. Okay, goal test is the final destination, which whether you have reached that final destination or not. Okay, the goal test here would check if the agent has reached Bucharest or not. Okay, this is basically a criterion used to determine whether a given state satisfies the goal to the problem. For example, if this in this instant it is possible to reach from one location to other location, that is from Arad to Bucharest, it is easily possible if there are no obstacles in between. Okay, so this would be the particular goal test. Next would be path cost. So now what is this path cost? This is a function that assigns a numerical cost to each path or sequence of actions taken by the agents. Okay, the path cost could represent factors like distance, time, or fuel consumption. The goal is to find a solution within the lowest path. Okay, for example, in the same example again, from driving from Arad to Bucharest, some of the key factors you should be remembering that you should be taking as path cost, that is distance. How much distance is required to go from Arad to Bucharest? That particular number is called as the path cost. Time. How much time it is required, if you drive at what speed, if you drive at what distance or what speed that car, how much time it is required to reach the destination, that is the path cost for the time. Or fuel consumption, how many fuel or how much petrol or diesel you would be taking to reach your particular destination. Okay, these all things come under path cost. The goal is to find a solution within the lowest path cost. Okay, the goal is you should be finding a solution within in order to achieve lowest path cost. In this case, the lowest path cost would be appearing when you, for one, if you want to reach to Bucharest in this example, if you take shortcut routes, okay, you would be able to travel a short amount of distance, so that you would be reaching in the highest possible time, and also the fuel consumption would be less. So in this way you can uh, find a solution with the lowest path. So this comes under path cost. Next is state space. This comprises that all possible states that the agent can reach from the initial state through a series of actions. The state space can be visualized as a search tree where each node represents a state and the branches represent actions connecting the states. State space means what are the obstacles you would be appearing when you reach from one location to other. Okay, through a series of actions, how you would be trying to resolve those problems. Okay, here the state space can be visualized as a search tree where each node represents each set of problems or each set of actions you would be taking for separate instances of time in order to reach your location. Okay, so this comes under state space. Okay, so these are the key components in you need to be considering you which for to just defining a problem in a problem solving agent. Okay, by defining these five components, a problem can be formally represented. Okay, a particular problem in this, which in this case I mentioned, is from traveling from Arad to Bucharest. What are the set of key considerations you should be taking? Okay, I've discussed it. By enabling problem solving agents to search for a solution by exploring the state space and finding a sequence of actions that lead from initial state to goal state. Okay, hope you understood this question. I've tried to explain as much as possible, guys. Okay, so if you had listened to my video, you would be understanding it. So let's get to the next question now. What is the eight puzzle problem and how it is structured? Okay, so this is one very important question, guys. So this would be appearing in the exam as well. Okay. So what is this eight puzzle problem? It is basically a grid, okay, where it consists of nine squares. Okay, it would be consisting of nine squares where one square is empty, and they will be giving you one initial state and one final goal state where you should be reaching the final goal. Okay, for example, if you had played magic squares and all, where you should be shuffling the squares, okay, where one square would be empty and you should be moving other squares and finding the solution. Okay, so that basically is the eight puzzle problem. So, okay, I will be showing you one image now so that you would be clear about this eight puzzle problem. Okay, so see here, this is basically an eight puzzle problem where, as I've told you, it is of nine square sets and one square would be empty, and they would be giving you an initial state where the numbers would be completely shuffled here. Okay, and the final state here is arrange it in this manner. Okay, you should be arranging it in this manner by shuffling the squares. Okay, keeping the one square empty, because one square is empty, you can shuffle it. Okay, yeah, our final state is you should be you should be keeping the numbers in this sequence. Okay, starting from 1 from the second square, 2 from the third square, 3, 4, 5, 6, 7, 8. Okay, from this initial state. How you can do this? By just interchanging the numbers. Okay, by arranging it. By if you want to go 1 to be coming here, what you should be doing, you should be moving the 6 like this and then 1 upwards. Okay, then what it becomes, if you move 6 like this and 1 upwards, this box would be empty. Okay, now, if you want to move one upwards till here, you should be making the what to say path for one to be traveling from one point to other point. Okay, from this point to this point. So that should be taking other numbers aside, and you should be making that one fit at this position. Similarly, if one is fit, then you should be fitting 2, 3, 4, 5, 6, 7, 8 at the particular position. Okay. So from start state to goal state. Okay. So this is completely a 8 puzzle problem where state they have mentioned it as a state description specifies the location of each of the 8 tiles and the blank in one of the 9 spaces. Okay, the initial state that I mentioned it. Any state can be designated as the initial state. Okay, this is not the particular initial state. They have in this they have mentioned this. In if you want to if they could be giving any other initial state as well where the numbers should be completely jumbled. Okay, that what they have told it here. Note that any given goal can be reached from exactly half of the possible initial states. Okay, actions to be taken. In this, what actions can we take? As I've told you, you should be moving these tiles, okay, or these squares. That I've told you. See here, the simplest formulation defines the actions as movements of the blank space left, right, up, or down. Okay, if you want to shift these blank spaces, you can move these squares left side, right side, upwards, or downwards in order to get to our final goal state. Okay, so these are the actions to be taken. Next is transition model. Given a state and action, this returns the resulting state. For example, if we apply left to the start state, in figure 3.4 is mentioned, the resulting state has the 5 and the blank switch. Okay, that is, if we apply left here to the start state, that is if you want to move this blank space here to the left side, what you should be doing is you should be bringing this 5 you should be moving this 5 to the right side, so that the blank space will be shifted from this side to the left side. Okay. Next is goal test. Goal test is that this checks whether the state matches the goal configuration or not. Okay. For example, goal test is if you move one set of tile in one particular location, you should be checking for the final goal state. That is, you should be of this order. Okay, that is goal state for each possible uh, movement of tiles. It would be checking for whether it is matching our final goal state or not. This comes under goal test. And path cost. Path cost for this is each step costs one. So the path cost is the number of steps in the path. Okay, that is how much number of times steps you would be taking to reach the goal state. That would be a path cost for this case. Okay, hope it is clear. The complete 8 puzzle problem. In the answer which I provided in the PDF, it is completely the same thing which I have explained. It is in the theoretical part. Okay, let us discuss that as well now. So yeah, this is the complete 8 puzzle problem question. Okay, you can see the 8 puzzle problem is a classic example of problem that can be solved using search algorithms, as I've told you. Okay, and these are the something the theory part, and this is 8 puzzle problem is consists of a 3x3 grid with 8 numbered titles and one empty space, as I've told you. Okay, the goal is to rearrange these titles from a given initial configuration, that is the initial state, to a specified final state or goal configuration by sliding the titles into the empty space. Okay, by moving the tiles. Okay, using the 5 components described in the sources for formally defining a problem, we can represent the 8 puzzle as follows. First is the initial state actions. Okay, that is these are the set of actions you should be taking. That is moving the empty space up, moving the empty space down, left, right. Okay, as I've told you. Next is goal test, path cost, state space. Everything I've discussed it in that PDF. Okay, so these are the complete set of actions you need to be taking places. The 8 problem can be visualized as search tree where each node represents a state, that is a tile configuration, and the branches represent the possible actions. Okay, so in this way the search tree could be built where each node of that search tree represents a state, that is the tile configuration at which position it is there. Okay, and the branches, that is the the node, from each node the branch would be forming, right? Those branches represent the possible action, that is what and all the possible moves we can do in order to get to a final state. Okay, solving the puzzle involves finding a path this tree from one initial state to the goal state. The process of finding this path is known as search. Okay, and there are various algorithms for doing so efficiently, such as breadth first search, depth first search, and A star search. Okay, the process of finding the path in the search tree, okay, in this for this problem is basically known as search, and there are different kinds of search. In order to, if you want to execute, there are different patterns of search. Okay, first is breadth first search, depth first search, and A star search that I'm going to discuss in the upcoming questions. Okay, so that's all for this question, guys. Hope you understood this 8 puzzle problem clearly. Detailed explanation I've provided for this answer. Okay, yeah. Let's get to the next question now. 4A. How does the breadth first search algorithm work? Okay, so what is this breadth first search now? Let us discuss that. The breadth first search is a simple strategy in which the root node is expanded first, then all the successors of the root node are expanded next, then their successors, and so on. Okay, as I've told you about the search tree, right? So this is basically a search tree here in this figure you can see. Okay, how basically a search tree looks here. You can note it down. Okay, the nodes and the following branches. Okay, so this is the basic algorithm of breadth search. How does it work? It is mentioned here. Okay, so this is at the topmost part of the node. Okay, this is the root node. Okay, where from this root node the particular subnodes are expanded here, and these are the particular set of levels where the topmost layer is called as level 0, and from that it is divided into two, so this is called as level 1. Again from these two it is again divided, so this is mentioned as level 2. Again from these things they are divided, so this is level 3, and finally we have level 4. Okay, so this is our initial state here, and from this you should be reaching this final state here. How you could be reaching here is, you can see here. Okay, this is the particular path here which they have mentioned it here. In this path you should be traveling, you should, in order to be reaching from initial state to final state for breadth first search. That is, from topmost node you should be coming to the just follow these arrows here. From S you should be going to A. Okay, and from A you should be going to the same level. Okay, what is the next component in that level you should be checking. That is from A, the next component is B. Okay, and now level 1 all the components are cleared. Now from B should be going for the level 2 first component. That is from B, you can see here next component is C. Then in the line we have D, G, H. Okay, then after H you should be jumping to the next level, that is level 3. The first component is E. Then after that, following it, we have F, I, and finally we have K. Okay, so this is the path here. Start from here, go like this, and again come back here, go like this, come to E, go like this, and finally K. So this is the algorithm of breadth first search. Okay, as they mentioned it, let's see first S A B C D, that is S A B C D, G H E F, that is G H E F I, and finally K. So in this way, the breadth first search algorithm works. Okay, hope it is clear. In general, all the nodes are expanded at the given depth in the search tree before any nodes at the next level are expanded. This is achieved very simply by using the first in first out queue. Okay, FIFO stands for first in first out queue for the frontier. Okay, this is achieved very simply by using this queue here for the frontier part. Okay, first in first out. Okay, so these are basically the breadth first search trees you need to be drawing for different states. Okay, if you want to represent for different stages, you could be simply drawing, that is you can, they have mentioned it here. See, this is the first stage where this is the topmost node, and if you want to check go for the next path, you should be going for B, then C, where this arrow mark indicates the direction of the path. Okay, in the second level. Okay, and from this level we should be starting from this next level 3. Okay, again this is the path here, moving at this path, and so on. Okay, for all the DFS trees goes on. Okay, you can represent it. So this was all about breadth first search algorithm. Okay, hope it is clear. Next we have one more kind of search, 4B. What is iterative deepening depth first search and how does it function? So what is this iterative deepening depth first search? Again, this is very easy. The iterative deepening depth first search is simply called as deepening search, that is IDS. Combine the benefits of depth first and breadth first search to find the best solution. Okay, this comes under iterative deepening search. It gradually increases the limit from 0, 1, 2 and so on until it reaches the goal. Okay, it will terminate when the depth limit reaches D and the depth of the shallowest goal node with the success message. Okay, you can see the algorithm here. Okay, the limit 0 represents the first level, whereas the limit 1 goes to the next level, 2, 3 and so on. Okay, so if this is the first node here, main node, root node, from this here the iterative deepening search goes like this. For example, this is the first node. If you it checks whether the possible solution is there for this node or not, and if it is not there, this would be completely negligible, that is it would be we should be shading it completely black, and should be checking for the next limit, that is limit 1, where we have one more separate sub nodes, that is B and C. Okay, that is it again checks at node B. Okay, and it checks whether at node B you have any solution for that or not. Okay, that is if in this instance whether we have any solution at this point. If we have the solution, then what it does is it goes to the next limit too. It won't check for the next limit. For if for example, if you don't have anything in this path, or this path is of no use, then what it does, again I've told you, right, it completely should, it gets neglected and goes to the next part, that is C. Okay, and whether if in C also, if it's completely of no use, then it jumps to limit 2, where the third level would be coming, that is another set of sub nodes of B and C would be activated, and it would be checking like that. Okay, for positive instances, what it does is, as I've told you here, for B, if this is positive and something is, if it is available here, then it will be checking for directly, it would be jumping down here, and if this is not available, it will be jumping to node C. Okay, and in this way the iterative deepening search works. Okay, by analyzing the breadth first search as well as depth first search. Okay, so this was the complete answer. Okay, you can note it down along with the algorithms here. Okay, limit 0, 1, 2 as mentioned here. So this will be coming for 10 marks, so please note these points down. So yeah, that's all for this video, guys. I've tried to explain as much as possible, guys, so you should not be complaining that explanation is not proper. Okay, so as much as possible I've tried to explain from my side for this video. So please watch this video completely and give your prestigious opinions in the comment section. Comment section is all yours. You can write whatever you want. I promise that I won't be deleting it and I will be replying to each and every comment because your comment is valuable to us. Okay, whether it be positive, negative, I literally don't care. What matters for me is you should be commenting. That's it. You should be giving your opinions. Okay, that would be making me satisfied. So that's all for this video, guys. Like this video, share this channel to a huge number, and give your opinions whether you like this video or not. And in the next video, we are going to see with module 3 solutions. Okay, so stay tuned for that as well. All the best for your exam, guys. Thank you.